Alright, so this is problem 6.18 out of Griffiths. So again, before I start, please like and sub. Really appreciate it. I'm going to keep making more videos, working through problems out of Introduction to Quantum Mechanics, 3rd edition by Griffiths. So if this is a class you're taking or will take, or just something you're interested in, I think it would be beneficial to go ahead and subscribe. Okay, so it says part A, show that the translation and inverse, so that's the parity, don't commute. Okay? So we have the translation operator and our parity operator. We'll multiply that by some function. I'm just going to call it psi of x. Okay, so we have this situation here. Just doing our commutation relation. Okay. And we know what parity does, and we know what the translation operator does. So we're going to get the translation operator acting on now psi of minus x. I'm just going to add this over, and that's parity operating on psi of x minus a. Okay? So the question is, does this equal 0? Well, let's find out. I added that over, and I did the translation operator and the parity operator. And now we're going to do the last operator here. So this is psi of minus x minus a. This is psi of minus x minus a. So we get psi of minus x minus a does not equal psi of minus x plus a. So they do not commute, and we just showed that. So that is what we needed to do there. Part B says, because of the translational symmetry, we know that the eigenstates of H can be chosen to be simultaneous eigenstates of the momentum, namely that equation, which I'll give you. So that the parity operator turns f p of x into f of minus p of x. These two states must have the same energy. Okay? So the equation that they're referencing is this one. F of p of x, this is in the textbook. 1 over 2 pi h bar squared e to the I px over h bar. And if we let parity operate on this, the constant's not really affected. It's not at all. And your x essentially becomes negative, but I'm going to put the negative with the p. And this is f of minus p. F minus p of x. And if this is a free particle, it mentions that. It's a free particle in one dimension, so your Hamiltonian then is just equal to p hat squared over 2m. So you see it doesn't really matter if this is plus or minus. You're going to get the same energy. The same energy. Okay? So I think we showed what they wanted to show there. And part C says, so now what they want us to do is we want to show that the translation operator mixes these two states, the two states they give us. And so there must be degeneracy. So just as an example, we're doing t of minus a. We'll start with 1 over pi h bar square root. And it was cosine, so this was the first state, px over h bar, which is 1 over the square root of pi times h bar, cosine of p over h bar, x minus a. Okay? And now what we need to do is the sum and difference. So for cosine of a plus or minus b, that's equal to cosine of a cosine of b. Oops, pen's acting up a little. And then it's minus plus sine of A sine of B. And if you apply this to this difference that we have, you're going to get the following. You're going to get 1 over the square root of pi h bar. And then you're going to get cosine of just px over h bar. And then cosine of our other term, which would be pa over h bar. And then because there's a minus sign here, we're going to take the positive, and you're going to get sine of exactly the same thing. Okay. And if we have it operate on the other state that they gave us, it was the exact same thing, only a sine instead of a cosine. It's going to work out exactly the same for the most part, but our sum and difference formula will change because sine and cosine are different. So same exact idea, nothing crazy here. And now what we need to know is that sine of A plus or minus B, so the situation that we have is sine of A sine of B. Sorry, sine of A cosine of B. That's equals 2. And then plus or minus, and now it's cosine of A sine of B. So in this case, we're going to subtract. Okay? So we'll get 1 over the square root of pi h bar. So we'll have sine of px over h bar, cosine of pa over h bar, and then it's minus cosine of px over h bar, sine of pa over h bar. And those are your two states. So hopefully that helped. If it did, please like and subscribe, and I'll be sure to post more.